Okay, in this video, we are going to study a set of questions that are used to analyze word problems. For this unit, we're using these 5 questions for linear problems because we're studying linear functions. However, these same 5 questions can be asked of every function family that we will study for the rest of this year in Algebra 1 and as you move forward into your other math classes. So it's important to get used to asking them and answering them for your individual problem. The first one is, after reading through the scenario, how would you label the y-axis? What are the units of the y-axis? What are the units of the x-axis? Next, what is the meaning of the y-intercept in this problem? Next question, what is the meaning of the x-intercept in this problem? If there is not an x-intercept, say why there's not. And this will all become clear as we work through these questions and as we do the scenarios. Next, what is the slope of this function? And what does it represent in this problem? What are the units of the slope? Is the function increasing or decreasing? Obviously, if the slope is negative, then your function is decreasing. And if your slope is positive, your function is increasing. And lastly, what is the domain and range of your function? What is the set of all possible x's, inputs, and the set of all possible y's? What's the range and the domain of those items? So let's get started with our first scenario. So your family's going to the fair. It cost $20 for an entry fee, and your family brought their own food. So the only additional cost are the ride tickets, which are $3 each. So answer the 5 questions for the following function that models this scenario. So for this model, we are going to be looking at an equation. Okay, we're looking at an algebraic equation. So let's get started. Question 1. How would we label the y-axis and the x-axis? Well, we know that x is our independent variable and y is our dependent variable. Okay, so let's look at what we have. We have our slope, which is always associated with x. Our rides are $3 each. Well, that tells me that our x is the number of rides we take, and y is our total cost to go to the fair in dollars. So now let's go to the next question. What is the meaning of the y-intercept? Well, the y-intercept is the number 20, right? Look at the equation, it says so right there. But what does it mean? Well, it means the entry fee. That's what it means. So it means the entry fee. Next, what is the meaning of the x-intercept in this problem? And if there is not an x-intercept, say why. Well, let's think about this problem. Does it begin at 0, 0? Does the graph begin at 0, 0? No. When when x equals 0, what's y? It's 20. And every time you go on a ride, it's going to increase your total cost. So this is not only obviously an increasing function, see the slope is positive, but it starts at 20. So if you imagine this graph as a line, it's never going to get anywhere near the x-axis. So you don't have to worry about the x-axis in this instance. Next question. What is the slope of this function? Well, we talked about that. The slope is 3. See, 3x right there. And what does it represent? In this problem, when they ask you what it represents, they're asking you for the units, all right? Because the unit is what defines what these things are. If not for the word part of the problem, this is just another math problem, right? Just a bunch of numbers. But in this instance, this number means the amount of the dollars per ride. So the units of the slope are in dollars per ride. Okay. And last but not least, let's talk about the domain and the range. And I'm going to erase all of this so that this can be very clean when I go through the domain and the range. All right. So the domain is the set of all the possible x's. So when you're thinking of your problem, think, okay, well, can I have any negative number rides? No, we don't do that. On the other hand, is it possible to go to the county fair and not ride any rides at all? Yes, it is. So we can start with 0. And since 0 is available to us as a point, as a coordinate for x, we have to use a bracket with a 0. Now I know that for this problem, mathy-wise, we're going to use the infinity, even though we know that there's only so much time to be at the fair and there are only so many rides you can ride on. We don't know. They didn't tell us in this problem. So we're going to use the infinity symbol. So this is interval notation, just to remind you. I've mentioned interval notation a few times before. We also have inequality notation, and it's important for you guys to start getting used to dealing with both of these things. So in inequality notation, all of my x's are greater than or equal to 0. Okay? 0 is the smallest, and it can go all the way up to infinity, even though we know that it really won't. So this is the domain. All right, so now let's do the range. So once again, what is our smallest y value in terms of our problem? Well, if we can't go below 0, what is our y value when x equals 0? It's 20. So in this problem, our range has to start with 20. And because you're allowed to go to the fair, pay 20 bucks and not ride any rides at all, we're allowed to have 20. So we use a bracket. But once again, even though we know that your dollars are limited, you don't have an infinite amount of money. Not even Bill Gates has an infinite amount of money. then for terms of the math problem, we can put infinity and then a parentheses. And for inequality notation, we're talking about y's, we're talking about range, and all of our y's are greater than or equal to 20. And that's inequality notation. In the next video, in the next two videos, we'll do the same thing with a table of values and also a graph. See you in the next video.